Question 6. When tested in a cool garage at 10 degrees Celsius, a motor tyre is found to have a pressure of 1.2 newtons per centimetre squared. Calculate the pressure after the tyre has been allowed to stand in the sun so that the temperature rises to 37 degrees Celsius. You may assume that the volume of the tyre remains constant. So there's a couple of parts to this. So first of all, we're back to using the combined gas law. Except here, we're assuming the volume remains constant. So we could write P1 over T1 is equal to P2 over T2. Secondly, we need to be careful because the temperatures are in degrees Celsius. So temperature 1 is not 10 degrees Celsius, it's 283 Kelvin. And temperature 2 is not 37, it's 310 Kelvin. The pressure is in newtons per centimetre squared. Doesn't really matter, it just means that we'll get a pressure at the end in newtons per centimetre squared, but since we're thinking about it, we could quickly check that we know how to turn this into pascals. So a centimetre squared is 1 centimetre by 1 centimetre. A metre squared is 100 centimetres by 100 centimetres. This is 1 metre squared, which is 10,000 centimetres squared. So to go from a pressure that is 1.2 newtons per centimetre squared, we're going to need to convert this. We're going to multiply this by a conversion factor. That means we replace the bottom unit. So I'm going to put centimetres squared over metres squared. When I multiply this, the centimetres squared cancel out and I replace them with metres squared. And I already know that the number of centimetres squared per metre squared is 10,000. So 1.2 newtons per centimetre squared is 1.2 times 10 to the 4 newtons per metre squared, or pascals as we typically call them. So that's what that pressure means. We didn't need to convert it in this question, but in case you did any conversion of units. So we're trying to find the new pressure P2. So P2 is equal to P1 T2 over T1. So P1 1.2 or 1.2 times 10 to the 4, if we're doing it in pascals, times temperature 2, 310 over temperature 1, 283. That gives us a new pressure of 1.05 times 10 to the 3. So we always round to the right number of significant figures, which here is 2. So 1.1 times 10 to the 5. No, sorry, I've done the calculation wrong. Let's try that again. 1.2 times 310 divided by 283 is 1.3 newtons per centimetre squared, or if we were writing it in pascals, then 1.3 times 10 to the 4 pascals, or newtons per metre squared.